Hello everyone, so today we will learn about Facade design pattern. This is one of the structural design patterns which are concerned with how the classes and objects can be composed to form larger structures. This pattern is used to provide a simple interface to a complex system of classes, objects and interfaces. It aims to hide the complexities of the system and provide a single point of access for the client to interact with the entire system. So consider we have an e-commerce system, okay. So in this suppose we have some complex system for inventory, okay. So we have this inventory system, okay, and then we also have a payment system, okay. So we have an inventory system and a payment system. So inventory, this is for checking the stocks, how much the stock is available and all. So this system is for that, and this is for the payment system for various payment options and all such things. So let us consider these two are some complex systems we have. So now suppose we have a client which is accessing these two systems. So the user places the order. So this client application, sorry for the text which I'm writing. Yeah, so this client application, so first before placing any order, it would check whether the stock exists or not in the inventory, and then if the stock exists and if we get such a response from the inventory system, then it would connect to the payment system and complete the processing of the order. Okay, so this client has to handle all of this checking in the inventory and then placing the order. Okay, so this is a bit complex, and then this is also not something which is very flexible and which is something which we don't want the client to handle all of these things. So in this Facade pattern, what happens is, so all this internal calls to the systems are handled by, let us consider it as a front controller or something. So front controller or a front service, if we say. So this is nothing but a Facade, okay. So what it does is it will have the instance of inventory system. It will also have the instances of the payment system. So the client now can directly connect with this Facade and then it will get the response. That's it. So it will give all the details which are needed. So this Facade would act like a kind of a front facing to the two complex systems which are there behind, okay. So this is the Facade pattern. So this Facade would then connect with the inventory system, get the details, and then it would connect with the payment system, get the details, and then revert back to the client. So even if we have any modifications in the future, we can directly update this Facade, and that would be pretty much easy and more flexible than changing the client each and every time, right? So let us see the live implementation of this example. So we have this inventory system. So consider it as a class for now, but in real scenarios, you will have a very complex system, maybe an inventory or maybe a complete service altogether or a complete project altogether. Okay, so for now, for our understanding, we have this inventory system. Okay, and it has two methods. One is to check if the stock is available or not. And then we have another method to update the stock. So whatever is the quantity, we will update the quantity. Okay, we will pass in the item name and we will update the quantity, or we will pass in the item name and the quantity and check if that much stock is available or not in the inventory. And then we also have this payment system. So for now, we just have this one method, process payment. We are just passing in the card number and then we are processing the payment. So let us, like these two, we can consider as some complex systems. So now, as we have seen in previously, so we have this client. Okay, so now if the client has to place an order, first it has to have some instance of the inventory system and then the payment system, and what are all the details which we have to pass. And then it would check, like in the inventory system, if the stock is existing, like if the stock is present of this much quantity for this item, then we will contact the payment system and then we will process the payment for this particular item and quantity and then update the stock. Okay, so consider this example. So here all this complex implementation is done by the client itself. which we do not want. So what we will do in the facade pattern is, so we will have a facade. Okay, so we will have a facade wherein we will have the instances of this inventory system and the payment system within the facade itself. Okay, and then we will just have that one method place order, which the client can call and pass in all the desired things, and then directly this facade will contact these two services and then it would give back the result. So instead of all this logic over here, what we can do is we can directly use the facade. Okay, let us just comment this out. So what we can do here, we will create this facade instance, okay, equal to new order facade, and then what the client can do is, let us take these, we will need these, right, to pass into the order facade. Okay, let's make it more readable. Yeah, so here we can directly call the order facade dot place order. We will pass in the item, quantity and card number. So isn't that simple for the client to directly call this facade and then place the order instead of handling all these complex systems by itself. So this is the facade pattern.
The main advantages of this pattern are, it improves the maintainability and flexibility of the code base because we just have the facade class to maintain, and also it makes it easier to add new features and functionalities in the future because we just have to update the facade class to add more or to contact more complex systems. If you like this explanation, hit the like button, subscribe to my channel and hit the bell icon to get notified for the next videos. Thanks for watching.